Colorado Boulder. She works with Dr. Ami Foida in the Philanthropic Information Research Lab, and she focusing on how political nonprofit use data to influence their audience. So prior to CU, she worked throughout the nonprofit sector as a union organizer, a refugee case worker, and policy writer. Shiva received her BAs in international politics and philosophy from Penn State University. So now, Shiva, time is yours.
Thank you so much, Ava, and thank you all for coming today. So I just want to share my screen and try to start setting up so that I can see the chat while you're talking. And let me figure out a way, sorry. Can you all see my desktop? Okay.
Yes.
And let me also bring up the chat.
So everyone can ask question by sending some message at chat box ya Siva during your session. Ya, oke teman-teman. Jadi kalau teman-teman mau ada pertanyaan silakan bisa disampaikan di chat box. Boleh bahasa Indonesia atau bahasa Inggris. Bahasa Indonesia juga boleh. Nanti di sini ada Mbak Dewi Barnas kan yang bantuin saya, Mbak Dewi Barnas. Oke, Siva, please.
Okay. No, I'm sorry that I only speak English. So welcome to today's tutorial. This workshop is going to be about text mining, and I want to just give an introduction just for the game plan for the next 2 hours. And so I want to start off with a brief introduction about text mining and natural language processing generally. And we're going to go into the steps about building a corpus and cleaning that corpus and doing some analysis. I'm going to go over both the Python version of everything, as well as share some software to help ease this process. And so I don't expect anyone to follow along with the Python. I'm really just demonstrating it to show you how these softwares work and how we can best use them in order to get results specific to your data set. I'll be sharing all of the code later on, so really don't feel any need to follow along, but please feel free to ask questions. I will try my best to answer. I may have to ask for Ava's help along the way, but yeah, so let's get started. Oh, and I will try to leave a couple of minutes between each section so that you can ask questions specific to that topic, so that we aren't jumping back and forth. But of course, like if something comes up later, I'm happy to take those questions too. So getting started, natural language processing is this term that we keep hearing over and over again. But really all it is the computational interpretation of language. And so it started off being about actual conversations and conversational text such as tweets, and it's developed into something that can be used to analyze any sort of corpus that you have. And you see it commonly every day. You encounter it every day with your spell check, with your autocompletes, and you interact with NLP systems when you're using chat boxes or transcribers. And so today we're going to try to shift over to like using NLP ourselves instead of being the end user, trying to manipulate NLP to our benefit in order to help us with strategic readings of our corpus. So like the tools that you're going to see today aren't actually going to conduct the analysis. What they're going to do is they're going to speed up your process through the analysis. And so specifically with the two analytical tools that we're going to be going over today, they'll help us with finding strategic readings of the text in order for you to go and do some qualitative research. And so I wanted to start off with and spend a lot of time generally about topic modeling. And so topic modeling is basically, here you see some examples of Sprouts Coffee has done an analysis on their own, on the tweets that are mentioned on their own page. And so the way that they've done this, just a basic background, is that they've collected a sample of their own tweets. So they've went and gone to the past like 1,000, 3,200 tweets, and they basically looked for the most common words first, and then tried to find what words co-occur and show up in the same tweet as those words. And so I think it's most straightforward to talk about the hashtags. So, you know, it's very straightforward. Everyone knows like and sees that hashtag. So they're just doing a simple count of how many times like it says Sprout blend, so like their special coffee blend has appeared. And then they're looking into that tweet to find the individual words that have most commonly appeared with that tweet, within that tweet that has that hashtag. So something like Sprout fail has like, oh, someone got the wrong coffee order, right? And so we see the words wrong and order at the beginning of that model. Yeah, so very generally, like that's the basic of what a topic model is. And the tools that we're going to go over today can actually go into and find those topics, the tweets associated in that topic. Are there any questions about what a topic model is?
Not yet, you can go ahead. Ada pertanyaan, teman-teman, untuk topik modeling? Belum sih? Not yet, Siva, so you can go ahead.
Okay, so now let's think about the first step to what they did. That Sprouts example, what they did was they knew their question. They wanted to know what people are talking about when they're interacting with their Twitter account or what's being tweeted. In your case, you know, we all have our research question in mind and we roughly know what kind of data we want, right? But the thing is that like when we think about the common places that you find data, and the common websites that they appear on, they're all very drastically differently, they're all formatted drastically different, right? So like we're all familiar with what Twitter looks like. And we know how different that is than what Wikipedia looks like. And so we can't just use the same code to copy and paste the same, we can't just use the same code to scrape tweets across or scrape information across different web pages. And so we're going to need some familiarity with the actual topics that we're looking at. And so let's look at a tweet. Let's say we want to look at Twitter. And today, for today's tutorial, I'm going to show you how to scrape information from both Twitter and Wikipedia. So, you know, this is a tweet. This is what our country has been dealing with for the last few years. And so let's think about the components of the tweet, right? Like we're familiar with what a Twitter feed looks like, but you know, a tweet is not just these few words. It's not the 270 characters alone. It's also, you know, who posted it, what time they posted it, where they posted it, how many people interacted with that post. And, you know, whether it was a retweet, there's all of this information, like the background color of the tweeter's page, you know, all of these things like matter, or all these things are information which is kept and associated with an individual tweet. And so when we scrape that data, it doesn't look like this, right? It's not just going to be like, it's very different than just copying and pasting the information, because we're taking all of that extra information, which is referred to as metadata, and we're also storing that. And so we're going to go into file type soon, but I just want to show you, this is 3 tweets. So you see that they're separated by the spaces there, and it looks like a lot of information. It kind of is, but not really. So like, oh, sorry, I can't click. Do you see my mouse?
Yes.
Or, okay. So we see that this tweet was created on February 18th at this time. And we see that every single tweet has that information. Like this one is a few minutes earlier. And so there's all of this information has been stored like in this format, and you're viewing this in a JSON file format. The kind of file you choose is going to be very important in terms of when it comes to analyzing it and cleaning it and finding the data that you want. And so with Twitter, it's very straightforward, where you end up calling the category name. So every single tweet, it says like right here, it says created at, you know that's the date. It's always going to be called that field. It's going to have follower count of that person during the time of that tweet. And so it stores all this information. And so you can use these things. So I should always talk about the ethics of downloading Twitter data. I know that the downloading packet included a bit of information and guidance on how to actually set up your Twitter API account, your Twitter API with the developer account. And the goal is to download only as much data as we need, and only as much information as we need. But starting off, especially like when we're beginners, sometimes we don't actually know what we need. And so for initial practice especially, it's fine to download. It's a common practice to download and play around with things. But when it's time for you're professional at this, and you will be soon, you should try to download what you need and store it safely and make sure to dispose of it when you're done. Because we're really just using these as, these are often large scale analyses, and we're trying to understand what the trend is and what people think, and as opposed to what individuals are actually saying. Okay, so I want to actually go into scraping some files. So let me start off. Your download tutorial also had some information about how to actually set up the API, but also set up a Python and download Python and set up the Jupyter Lab and notebook. For the purposes of what we're doing, it doesn't really matter if you're using Jupyter Lab or notebook. I prefer Lab, but okay. So the main, I'm going to start off first by sharing with you the code for scraping a Wikipedia page. And then we'll go into a Twitter page, and then we'll go and use the software together and spend some time on that. And so the power of programming languages and Python is that thousands of people are working on it together. And so in order to do something, there are so many people that have created algorithms and functions in order for us to quickly use, so that we don't have to reinvent the wheel each time. So what I mean by that is something like Pythagorean theorem, like a squared plus b squared equals c squared. Instead of me having to type it out each and every time that I want to use it, I can just call a function that's already stored it and plug in the variables that I care about. And so all of those different functions are saved in what we call libraries. So in order to start this, I'm going to import a bunch of libraries, and I'll go over some of them in the coming hour or so. But for now, just know that these are tools that we can use that have functions that we can easily access to make our lives easier. And so our goal here is to define a function. So we want to create a function that we're going to call, like, let's get the article, and inside, when we're done with everything, so let me, when we're done and we want to actually do our end query, we're going to say, like, we're going to actually test it out there. Yeah, so currently I'm in, I opened up the Jupyter Lab, and I just created a new file. And so you can just, let me, I also have Jupyter Notebook open, but
Shiva,
literally just to show you.
Shiva,
Yes.
there is a question from Putri.
Yeah, I think I'm
you see that?
answering it, I think. Yeah.
Yes.
Yeah. So, sorry, Putri, I'm currently, yeah. This is in Jupyter Lab, but here in Jupyter Notebook, just to show you, you can press new Python 3 and it should open up a new document. And so, or in Jupyter Lab here, you can just press the plus and it should open up a new document. Or like you might be able to do file new notebook. Okay, so with this, we've imported a bunch of libraries, and we want to actually create a function that scrapes Wikipedia for us. And so wait, let me just also add insert something beforehand and make it a markdown so that we know what we're doing. Yeah, we're just working with Python for now. Okay. So when we create, so that link that we're going to have is going to include the web browser, like the web page that we want. So I'm just going to leave that as a comment. And we're going to try to get all of the article text. And basically, we're going to take the text into a string. That means to define that the letters are actual letters and words that we're going to read instead of other things, right? Because programming languages, they're all written in letters and numbers. And so we need to tell Python that we're distinguishing this and we want this to be interpreted as text. And so if it's not empty, we're going to take the information. But remember that a Wikipedia page has so many moving parts, right? Like imagine it in your head. You have like that heading, you have the sidebar, you have all of these different paragraphs with different headers and like, you know, there's a lot of things. And so we only need a few things from it. So we're gonna just take, you know, the name of the article, and we're going to distinguish each and every paragraph. And we want to make sure, you know, that we have some sort of like order and semblance. And so for every single paragraph, we're going to try to join them all together and have have a new line when that paragraph ends and the next one begins, so that it's all saved in a way that we can read easily. We're also going to remove the footnotes because that's a lot of extra space. And it makes it messy if you don't do that. And so let's just run this for now. And okay, so we ran it and it looks like nothing happened because we haven't actually told it to do anything, right? So in this case, we've basically like programmed a formula, but we haven't actually told it what the variable is. So let's say our testing tutorial is going to be the article about rabbits. And let's see what happens. Okay, so it processed that and let's print testing. Okay, and so now we have what looks to be the article about rabbits in paragraphs with new lines. Just to demonstrate why, like when I say what I meant by removing the footers, let me just comment that out, run it again. You start having these citations here, and sometimes there end up being actual links, but there's just things that interrupt the text a little bit. And so we're just trying to clean them up. And really, it's that simple. Like you can just copy this and put it in any Wikipedia article you want, and you'll have that. And you know, if in case you want to save it, what we do is, let me minimize this. In case you want to save it, you just have to like create a file, and like I'm literally demo file. I'm just calling it whatever I want. Yeah, I'll be sharing all the code at the end, so really don't worry about it. And so you create a file, and then we're going to use the append function. So in case I already have a file called demo file, I'm not going to delete anything. I'm just going to add to the end of it. And so, right, and I'm going to try to attach what I have for testing in there and then close the file when I'm done. And then, let's see. I don't know if my, oh, I'm sorry. This has to be in quotes. And so if I open up .txt, I should have it. My computer's a little slow, and so I don't want to demonstrate with that, but it's as simple as, oh, here we are. So we have rabbits are small mammals, and this is now stored in a txt file. And so, yeah, if there's any questions about scraping Wikipedia, I'm going to move forward into Twitter. So while I set up that part. Okay, I'm going to assume there's nothing. Okay, so when we're thinking about scraping Twitter, it looks very different than this. We're going to install a package called TweetPy, and it's used for Twitter. And pip install is really the function that makes sure that we have it downloaded. If this is your first time doing this, this might take a while, but my requirements are already satisfied. Yes, so for when you're scraping Twitter via Python, you definitely need the API code in advance. And I'll show you how we need it right now. And so basically, the libraries that we're going to be using are the JSON library and the TweetPy library. JSON is that type of file that I showed you in the Twitter data. This is a JSON file. So we need the library that will be able to easily read the functions associated with that file type, because we're going to save everything in that file type. So it's a very common, I'll try to enter some notes in there too, in case you missed something, but it's very common to use Twitter data in the JSON format. So now we need the 4 unique coders that are specifically for you and your Twitter developer account on that project. And so it's an API key, a secret, the access token, and the access secret. And so you should, I mean, I'm going to delete this after the tutorial, but in order for it to work, yes, you're going to need your, if you look into the download file, you'll see at the bottom, I think it's like the last thing, it'll show you how to actually access Twitter developer. And all you need is a regular Twitter account, and you can just upgrade it to a developer account. And usually you just have to write down like what you're using it for, and you're usually immediately granted a Twitter key and secret and stuff. So this is for my sake. Yours will be a different code, and I'm just going to try to scroll past it so we're not just, you know, there on that page for a while. So hold on. I'm sorry, I'm reading.
Yes, it's still.
Yes, it does. It does. So Crimson Hexagon does have similar functions. I am not actually familiar with it, but as far as I understand, it should be kind of similar. The reason that many people decide to choose Python is because you have a lot more control, right? You're the one actually writing every single function and stuff like that. So once you have those keys and tokens, we're going to really just take the key, take the secret, take that 4 bits of information, and we're going to authorize access from Python. So we're going to connect Python to the Twitter API. And, oh, and I missed one of them. And so, yeah, we're authorizing it using the TweetPy package. And since it's the only Twitter account I can look at, we're going to look at Donald Trump's tweets. I'm sorry, I'm really sorry. But let's, okay, run it. And of course, nothing happened. But we've just downloaded what I hope are Trump's 5 latest tweets. I think you can just increase that number if I'm wrong. So let's see. in order to print actual tweets, for us to see it in here so we know that what we're doing is right. So we're not just blindly pasting it into a file. So we're going to try to, let me also add my notes about this. So we already have this information. We're just going to demonstrate this before we do this. And let me make sure that when copying and pasting. Thank you so much for putting the link to the developer access account. And then let's print the output. Okay, so now we have a bunch of stuff. And so let me just quickly, okay, just what we've done is we've added an indentation of 4 just to make sure that each of these layers are separate so that it's easier for us to read. Otherwise, there's no real need. But you can see that like there's the text is here, the source is a separate line, right? Like all of that information that we saw in the JSON file is right there. And so also sort keys, just to like go through all the different nuances of this. So the indentation indents. Sort keys is going to show these things in alphabetical order, because otherwise it'll, just the default is to show whatever. It may be in order of appearance, but I think this gives it some sort of semblance. And so, no, it's not. It's not in order. So, okay, so the JSON file, generally it stores in a set. Sure. So when we're taking a JSON file, when we're collecting it, it stores it in a set. And what a set does is like the order does not matter. It's just like a bunch of information put together. And so we're saying like dump it all out. That's like the dumps function. And put the tweet, put it in an alphabetical order, give it some sort of semblance and print it out. And that's it. And again, similar to saving before, if you want to save again, we can just open a file, write that file to this and save it and we would be able to see it. Okay. Are there any other questions about that? Because I want to show you how to do it with software in case Python is too intimidating to do it with.
Gimana teman-teman, ada yang mau bertanya? Mungkin memang ini salah satu sampelnya aja sih, karena kita kan memang sifatnya lebih memperkenalkan ya di sini teman-teman. Mungkin tidak ada banyak yang tidak biasa untuk dengan Python, boleh juga coba-coba nanti setelah ini. Silakan kalau ada yang mau bertanya.
I can add something from the discussion.
Sure. Yeah.
For those who want to avoid coding, I think you can also use several softwares like Analytics, when you can scrap some Twitter data, but only for limited numbers. I think the free version can allow you to download around 1,000 tweets per keyword or per hashtag, and I think it's more user-friendly for those who want to avoid coding. I think I can provide the link here.
So yeah, you're correct. The default maximum is 1,000, but you can repeat it up to 3,200 tweets. And so you should be careful and strategic about when you're collecting data. You know, if you're trying to do something about a current event, you should try to be strategic about that. But thank you, yeah. And in social media macroscope, we'll be able to go over that too. In the tutorial, I didn't show you looping through, I'm sorry. Oh, here it is. In the tutorial, I didn't go through looping and getting all 3,200 tweets. The code that I showed will only get you 1,000 tweets. You need to add a for loop to iterate and repeat the process until that happens. And so from that download guide, there's this great closed source project called Social Media Macroscope. I think I'm logged in. It's the accounts are free. Ava introduced it to me the other day, and I wish I knew about it when I started this whole thing. But then I wouldn't have learned how to use Python. So I guess I'm thankful. But Social Media Macroscope has two tools, Smile and Bay. Today we're going to use Smile. Basically, once you have an account, which is like very quick, it's not like the Twitter API, you just sign up and verify with your email. You're able, I don't know if there's a paid version, but at least like with this, with the access that I have, you're able to have 3 open projects at any given time. And so I'm going to terminate the project I was testing and try to go to Smile and launch the tool. And here, I'm also just going to share the link into the chat. Yeah, I'm going to launch the tool. And when you're signing up, you have to specify what sort of social media you want to be scraping. I wasn't thinking, and so I just said that I wanted Reddit and Twitter. But I don't know if, oh, it says Facebook is here. I'm assuming that every logo they've included is here, I hope. But please correct me if I'm wrong. But we can get started. And this is their citation in case we end up publishing with it. And okay, so every single time, depending on what you've decided at the beginning that you want to actually be scraping, you'll have to authorize your account. And so authorizing Twitter literally just means like that I authorize the app and that I get a one-time code and I copy that code and I bring it back and I enter that PIN. And I don't believe you need a Twitter developer account for this because it didn't seem like this page right here or the page before it didn't show me like, it didn't, I don't think it said anything about that. But if I'm wrong, let me know. And so now that this check mark has appeared, don't click on it again because it'll make you authorize it again. Just click next. And so it says here, like, you know, that I've already linked my Twitter account, but I still have to link my other accounts. And so I'm going to go through this list. You know, I can look at tweets generally, or I can look at user timelines. And so let's go with user timelines. And let's add like what BBC. And one of the great features is that it adds it for me. So like BBC World. And let's look at the advanced settings just to see what it can do. So yeah, the default is 1,000 tweets. There is a maximum of 3,200 tweets that you can download with any API. That is a Twitter rule. That's not a limitation of any software. You have the option of excluding replies and excluding retweets. And you have the option of excluding any of that metadata that you did not want. By default, it will give you all of the information. And so let's search. And I invite you all to do the same thing to see if you have any issues with it. And so it shows me here all of the recent tweets. And I don't know, I think you can just go through all of it, honestly, and view it. And so the last part of this is just saving it. So you enter a file name that you want and you can save it and it'll download as an Excel file, as a CSV file. The CSV file that Eva had shared with you is actually just me scraping from this. It took like 2 minutes, you know, you see. Yeah, I don't know, I really love this tool. I wish I had it, especially for more difficult forums like Facebook and Reddit. I think it speeds up the process. No, so when it comes, so you can get the last 3,200 tweets of anything. So like if you're searching for a person like an individual account's tweets, it'll do the last 3,200. If you're looking at a timeline, it'll do a stream of the 3,200. And so you can't really specify what day and time that you want easily, from what I understand. Yeah. And it's part of why a lot of Twitter data is, you know, it's very rushed and it has to happen right then. And people are really just watching all the time. I also wanted to add the note about Facebook data. So Facebook has one of the strictest privacy settings in terms of what's open and what information you're able to scrape. Usually it's limited to public pages, it's limited to public posts on public pages, and like you might get aggregate like counts, but nothing like, you know, who liked it. Whereas with Twitter, you can get who retweeted that tweet and what else they added on that retweet and who commented on that retweet of the original tweet. And so there's drastically different amounts of information that you can get with different forums depending on their privacy settings. Are there other questions about scraping information generally?
Yes, ma'am.
Ya, silakan.
Is the reality in our place where we will look for this data, the social media that are most actively used are Facebook and YouTube. The most likely things to use a natural language program is to use API from Facebook and YouTube. But I don't have many sources to find the tendency of people if they don't use the two social media. I mean Facebook and YouTube. For Jakarta, yeah.
Yeah. No.
For,
go on, please. Sorry.
Okay. For Jakarta, which is the majority of Twitter user, but it's possible. But in my place, I think it is not effective because the sampling does not reflect the population. Maybe.
Yeah, that's a wonderful point.
Yeah. Maybe if we have used Facebook or YouTube, maybe it's effective mining a text for the project. Thank you.
Yeah. So when you're setting up your social media macroscope account, make sure that you include that you're going to download Facebook data. I don't think it has YouTube. I know that YouTube does like auto-generated captions that don't even work well in English. So I don't really know how well they'll work in other languages. But play around with social media macroscope, the Smile software, to see if like how much you can get. Unfortunately, we don't have time for me to go into another scraping right now because I think we need to get into cleaning so that we can move along. But yeah, it definitely does have an extension for some level of Facebook data. But you're right, Twitter data generally is not representative, right? It's people in cities, very few rural people, and it's like drastically different. Even with political leanings, there's more of one group than the other. And thank you, Yuri, for putting Netlytic. I will also save that for myself. So yeah, if you are not comfortable using Python, by all means use social media macroscope. It is a valid way to collect data. It is easier, right? Like you're here to analyze data and not necessarily just to scrape it and stuff. So use whatever is easier for you. Otherwise, like if you want to be customizable and to have more control over the kind of data that you're looking for, then go for the TweetPy and Python. So just to talk about file types very quickly. So the social media macroscope Smile, when you download that data, you get a CSV file. And let me try to find that CSV file. Instead of opening up Excel, and I took a picture of it. And so roughly, like this is what that file looked like, right? And so you can see the big difference between the JSON file and this Excel file. So the main difference here is that every single piece of information, like the label for what everything is iteratively, it's written for every single tweet in a JSON file. But for a CSV file, it's only written once at the top of the column, and everything follows that column. And so it's really important to be looking at these simple files that have data stored in them efficiently like this. So the three main file types that we recommend are the JSON files, but you're probably more likely to encounter the other two. So the CSV file, which is the simplest version of the Excel file, and the TXT file. And so this is a plain text file. It's put into a universal text encodement. And all I did here was I took that text column in the Excel and I just pasted it in here. And so like if we look close, we see that there are some errors, right? Like we see like these three characters together probably mean an apostrophe. It probably meant I'm coming back, or Baghdad's heavily fortified green zone. And so we see that it's not perfect and that we need to clean in order for it to make sense. And so I think that segues really nicely into our next portion, which is really cleaning data. And this is the bulk of the work. And this is where, like, if there's anything you're learning if there's any reason to learn how to use Python, it's for cleaning. I think that it speeds up the process a lot instead of you having to go and manually check and read every single document that you end up scraping. You can process files quickly, but there are some trade-offs, and I think that we can go, I think that my example will show that well. Just to overview, talk about cleaning, and I want to present this example of this sentence. So Miss White's home is a White House, but not the White House. She isn't the president of the US. The presidency belongs to someone else. And so we see that there are a bunch of words that are being repeated over and over again in these things. And they each mean something else based off of the context of the sentence that they're presented in. And so remember that Python and programming languages generally are very simple and dumb programs, to be very honest. What that means is that we see the word house and house, but Python doesn't know that they're the same thing because this has a capital H and this has a lowercase h. This has a comma and this has a period. So like what we have to do first, in order for Python to even understand that there are words here, we need to tell it to distinguish every space as a separate word. So like when there's a space, separate the words, and that's called tokenizing. We also need to tell it to remove this, the periods and commas, so that we can identify words that are the same. But that has some trade-offs, right? So here we have miss, and if we remove that period, it might make that word lose its value, right? Because like miss becomes MS, and MS could be a disease, it could be a master of science, you know, it really then depends on the context. Similarly, you know, if we take out all the capitalization, if we take out all the capitalization, we then potentially lose the meaning of US, because then US becomes us. And so there, you know, I'm mentioning these things to mention that there are trade-offs when you're doing something en masse, but there are workarounds to it. For example, phrases like US, when we're referring to the country, the word the usually appears in front of it. And so like you're not going to see the us unless there's a grammatical inconsistency. It usually means the US. And similarly here with White House and White House, the word the really does a lot of work by distinguishing that this is a proper noun and not just a White House. Again, though, that has trade-offs, right? So if the beginning of the sentence is just White House correspondent does this, you miss out on that thing by doing these blanket things. But when we're looking at big data sets, this helps a lot with identifying what we need. And so I'm going to And so we're going to be using the NLTK package, and it's a library that has an extensive amount of tutorials, and you can customize the different functions to your data set. And I'm just going to go over a few of the very common tools that we use with cleaning data, just to show you. But I have some strengths and limitations where I think like there's so many tutorials, and they have done a great job of compiling a list of all the different things you can do, but it's only really strong in English. And it takes a very long time to download with poor internet connection, so give yourself some time. And yeah, it's a lot of information, so sometimes finding exactly what you need can be a little hard. And you can only use it, like you can't really customize it very well. You can only just call the function and use that function. So with that being said, I'm going to go in and start cleaning some data. The slides in the notebook will be shared. Don't worry, the slides aren't that great, but I will share the notebook. So let's pretend that this is a new notebook. I'm just not loading that because I'm scared. I have a very delicate balance of internet connection right now, so I don't want to upset anything. But we're going to be using the NLTK toolkit, and because our data set that Eva had sent you all is a CSV file, we're going to also import the functions with the CSV. And so because NLTK is so big, it really is just establishing a connection and importing it, as opposed to like downloading specific sets. I do not have a notebook in Kaggle. I may be able to do that soon. Okay, and so we're also, again, just going to import very specific tools. And so some of that is, we're going to import the tool that separates each word, so tokenizing it, or separating each sentence and distinguishing them from one another. We're also going to remove stop words, which are the very common words that you'll see in a sentence like a, the, or, and then the last tool that we're downloading is the Porter stemmer. And so that, going back to that example, we have the word home and we have house. And we know that home and house are like they're related. But what Porter stemmer does is it reduces all the words to their root word so that we can pair them, so that Python can pair them. Sorry, let me get into a marked font cell. And again, I'm just doing this broadly, but we're going to open up that CSV file. And we're going to tell Python to read that as a CSV file. And so in order to read the tweets, we're just going to have to tell it to do that. You know, and so what we're using the .reader function from the CSV library, and we're saying read the CSV file and make sure that you change every tweet based off of the comma, because it is a comma separated file. That is the default because it's a comma separated file, but yeah. So now that we're reading tweets, we're going to start going through them. So we need a for loop to start doing stuff, right? And so what we're going to do is we're going to say the basics of what we want for every single tweet to do, and then we're going to use that for loop to just repeat that over and over again around every tweet. But the first thing that we need to do is tell Python what it's looking at, right? Remember that we have all of these different columns. And so if we want it to read the text column, for example, in Python, we start counting from 0. So the text column is 0, 1, 2, 3. The third column, so yeah, 3 would be the actual tweets contents. The day and time is 012, right? And so on and so forth. So I'm going to paste in a bunch of them. So like I care, let's say, about how many times it's been favorited, how many times it's been retweeted, the time, and then in that time, I care about the actual hour and minute that it was printed in. And so what I did there was I said, from that time column that we've already identified, take the 4th character until the 15th character. I looked at there and counted out. Like I don't care about I don't know if you see this well, but the first thing there is Tuesday, and then it goes to November 17th. And I just skipped over Tuesday and I took November 17th and the hour that it was there. And so that's characters 4 through 15. And then finally I took the text. So that's just telling Python what it's looking at, right? We haven't actually done anything. In order to actually do something, we're going to take that, we're going to say that original text. I want to keep that original text so that we can reference it. But let's, oh, sorry. Let's paste in, yes.
I want to ask something.
Sure.
If we want get text scraping, what the effective text if we in Indonesian or English, because NLP is basically English. The solution, we translate the comment in English and do the text to scraping, or how?
So I actually don't know. Eva, would you have?
Yes.
I think you would know better.
Yes. So Mas Aksan, I have some experience doing this when doing the text mining for Indonesian language. The problem is when we translate it to Bahasa Indonesia, when we translate from Bahasa Indonesia to English, there is a lot of bias from the translation process. So according to some research, some people in the US, students in US, we are doing a research. How is the bias? How much the bias is? It's almost like 10% for the bias. So it will be better if you use the original language. So in NLTK, they're offering the Indonesian section, so you can use that. That's
excellent. And Halim has posted in the chat a resource to with Indonesian NLP. So I hope that's useful. Thank you all so much. And so in order to actually do something, we're going to now start. And so we're going to say, take that 3rd column and let's make it all into lowercase so that we're identifying the same things. And so like if we print, let me get out of the loop. If we print the original text, that's a terrible tweet, but it is what we're getting. And then we print text. So we see immediately that everything is now in lowercase. Yeah, so I'm going to comment that out and continue. And I'm continuing in the loop, right? And so now let's also, I know that this example doesn't have anything. No, it doesn't. But we saw those weird symbols in this TXT file that I shared, right? And so like let's try to account for that. So what we can do is use the replace function with NLTK and just try to replace like the common things. Like we know that that's supposed to be an apostrophe, and we know that this just should be omitted. And so just very basic cleaning things up like that. And then also just to add, the next big step is to tokenize everything. And so tokenizing is making sure that every single word, everything that's separated by a space is its own entity. And so we can also, we can print the tokens and the words just to show. And you see the difference now. We're now in a list, and it's demonstrating every single thing separated by a comma now to show that there's different tokens that are there. And let me see, what else did we want to do? The alternative to that is showing sentences instead. Like if you don't want to, if you don't want it done by tokens, actually, we can keep that. If you instead want to do it by sentences, we can just say that we want it done by sentence and that our language is English in this case. And I didn't print that out. In this case, it shouldn't really matter because we're looking at tweets, and tweets are often in short sentences, but you see how it's all now in one, like under one set of quotes and one set of brackets. Well, the brackets will always be one. And then finally, which I guess this is sometimes dangerous and you can make sure to omit it, but let's omit some stop words. And so by doing that is we just look at the list of stop words in English in this case, and we add that as a variable, like we load it in. And we basically then just exclude all the stop words. And that's about it. And so at the beginning of this, we had created an empty list, and a list is just a bag of words, right? It's just holding in every variable that you have. And so now let's say that we are clean. And this is, let's say we imagine that this is all that we wanted to do and it's great. We would then just take that list. I called it all pros. I think I spelled processes. Sorry, post processes. And we're going to just add, like append, attach this last variable, right? So every single time, like, right, we had taken the variable that I named and identified in the previous time and have applied it here. Although I don't think I attached tokens too. I'm sorry, I forgot one thing. After we've tokenized sentences, we also want to get the root words of things, right? Like with home and house, we wanted it to be able to identify the same words. So that's called the Porter stemmer. And we're going to take the stem function and apply it to our variables. And so each time so far, we've been using the previous times variable in our new and storing it in a new variable. And so now our most updated one is called tokens3. And so we're going to attach anything that shows up in tokens3 and to our all post processes list. And then I'm going to just erase these to comment them out. But let's just print all post processes. I can't spell. Okay, and so now we have this whole list of, it's basically every single root word that you saw in the whole thing. And there's still things to clean, right? We just did a very fast thing, but you see that like there's like retweet here, there's like half links places, right? We might want to be able to erase those things, but you can see how things like intensify has only showed up in that way. You can see how president has showed up in preside as the root word. And so that's, and just to do a check to make sure that everything works, I'm just going to print the length because we downloaded, I think, 1,000 tweets, 1001. And so that's the basics of pre-processing and cleaning. I unfortunately don't have software to share with you about that'll automate cleaning. Eva, are you aware of any? No?
No,
yeah, so if there's any reason to use Python, it's really for cleaning, honestly, at least with the humanities and that kind of stuff. Okay, so if there are no questions, I'm going to go into actual analysis.
Shiva, I just only want to add something. So everyone, the problem in the different if you use Python for in Indonesian language is about the stemming, because you know that a bit different for the text, the structure of the words of Indonesian. So it might be a bit challenging for you to do the stemming process. So kind of that's only that.
Well, that's, yeah. Thank you for adding that.
Hi, Shiva.
Hi.
Hi, I'm Aditya speaking. I have a question. So thank you so much for sharing this one with us. Like especially for me, this kind of like a lot of stuff that we learn in like an hour. I have studied about this cleaning for the text mining for a semester before. So this is my first time using the Python. So I just want to ask your questions about like how do have you used the R program before for data cleaning, or this is like the one that you only use right now? Yeah, because I did use the R program before, and it's kind of like easier using this one rather than R. So I just want to ask your opinion. Thank you.
Oh, no, thank you for asking. From my understanding, and I'm not very familiar, but I think that it really depends on what domain you're in. So I know that like in political science, a lot of people use R, and that's very common. And so I think Python is easier, but I'm sure that they have their strengths. Yeah, honestly, Python, I go to Python because I know a lot of people that are using Python. And so if I have a question, I have many people to ask. And so I would also consider that. Yeah, but thank you for sharing. Yeah.
Thank you so much though, yeah.
No. And Mitchell, I think you had a question?
May I have a question from me, Michael?
Mm-hmm.
Shiva, I want to ask you, according from your experience, after you're scraping the data, what you use for do you use from this data for your work maybe, or for your jobs, and what the method you use for visualization and maybe for presentation of the data?
Yeah, so I do use it. My work is really all over social media. My first study was scraping different blogs, and now I'm starting to get into Twitter and Reddit and YouTube actually, but I haven't actually approached how to actually scrape YouTube yet. That is next semester's dilemma. But generally, I will share a lot of, it's not in today's tutorial, but later on, Ava will email you with a list of just libraries to look into. I know that GenSim does a great job. Beautiful Soup has a lot of tools, and like they're very easy to use. You just, and they have web pages for you to just look at like what function you need. And there's also a lot of tutorials that are very similar to things that we care about in digital humanities and journalism generally. So by all means, we'll share the library names, and I'll try to also share some of the tutorials that I've seen that I like a lot. Yeah, and since we're kind of running low on time, so with topic modeling, I just want to, so we went over what topic modeling was, right? It's this concept of looking at your whole body of text and trying to find words that are similar to one another and putting them into different topics, right? Clustering them based off of their similarity. And so there are many libraries that you can use that will really, like in a matter of like 4 lines of code, get you to actually produce a topic model, but just to show you under the hood so that we understand how these algorithms are working, I'm going to show you just like the long way of doing it, but I'm not going to go into any sort of detail. I'm really just going to do some hand waving. And sorry, just before that, there's a question I want to ask about lemmatization. I think this is a question for you, Eva. Is there a lemmatization for Indonesian language? Oh, or that's what you were just mentioning about how there's no root words are difficult. Yes. Okay.
Yes, that's right. So for some reason, I skip the process because when we do the lemmatization, it causes like very lot of bias from the result, especially if we want to make like topic modeling or something. So I suggested you don't have to do that because in Indonesian language, the term will be different when you do the lemmatization, kind of that.
Right, that makes sense. Okay, so with topic modeling, we're going to be using terms that are that we already used in the post process to make this easier. So we're not going to be you shouldn't open a new notebook for this. So basically, the goal of topic modeling is to partition the total tweets into different clusters, right? And the goal is for you to say that those words in a cluster have a connection that they don't have with other clusters, right? And so like a good topic model will show you a cluster that is about one subject and another cluster that's about another subject. And so, yeah, you want to partition the different tweets and the words in those tweets into those different clusters. Okay, but how do we do this, right? We start off by we have to start off randomly, right? We have to figure out how many words how many topics we want, as in how many of those clusters we want, and how many, and we need to create some sort of random initialization and a library to keep counts, right? Because there's a lot of moving parts when you're trying to figure out a topic model. You care about how many times a word appears in your total corpus, but you also want to take into consideration, like maybe there's something that's skewing your data. You know, maybe someone posted the word house like 40 times in one tweet, and that's just going to skew your results, right? So we need to have that balance where we find significant words throughout the entire corpus. And so we've initialized here like the number of topics we want, a dictionary to keep track of how many times a word appears. And so all a dictionary is it's different from a list. A list was just a bag of words, but a dictionary has a key, which in this case is going to be your actual, like a word that appears in a tweet, and the value. And the value will be, in this case, how many times that word appeared. And so in order to do a topic model, you're first going to need like a holistic analysis of the entire data set. And so what we need here, I'm just going to paste in all of it, but for everything in that, for all the cleaned files, right, where for every line in the cleaned files, we're going to keep track of every single thing that we're going, but I'm going to pretend, this is only 1,000 tweets, but let's pretend it's like 20,000 tweets. We're going to take a sample of that. In this case, because it's so few, I'm only going to take every other tweet, but like you might want to do every 10 tweets, every 20 tweets, depending on how much data you have. And so we're going to take like a random but representative sample of our entire corpus, and we're going to basically convert it into strings. And really the goal here is to try to understand the weight of the tweets based off of the words that appear. You know, like the idea is to find the words that will help us put words in different clusters. So we don't care about words like the, and whatever, right? We want words that will give us meaning and that are fairly unique to a subset of the corpus. And that uniqueness is based off of how many topics there are relative to the total corpus. So the first, in this global analysis, all we're doing really is we're just counting how many times every word appears so that we have some idea of what's going on in the data set. Okay, and so, and if we want to just see that it's working, we can print D, and that's the variable we're using to keep track. And yeah, it's 500 because we did every other tweet, so that makes sense. So now let's go into the local analysis, right? So after we did the holistic count of how many times each word appears, we now care about what's happening in each tweet, because we need to start looking at that relationship between the tweets. So it looks kind of similar, but that's because we want it to be in the same format. However, we're doing a new process where we're saving two different lists, and each document is one tweet, or like each docs, sorry, is one tweet. And so we're storing all of them together in order to understand what's happening. And so here, like the first loop here, this loop, what it does is we're going through every single tweet, like every line, and we're going to check if we have any significant words in that tweet. And significance here, we've defined it, specifically in this line. What we said was we want that word to appear in the corpus more than 10 times, but less than, in this case, 1/10 of the total corpus. Because again, we don't want, like, we know, like, the National Rifle Association is going to talk about guns, right? We don't need that in our, like, taking up space in our topic model. These are the numbers that you're going to have to play around with in order to find that sweet spot where you get meaningful information. So then we check, what do we do next? Sorry. Yeah, so like that's basically, this is how we've defined like an interesting word, right? And now all of this, we've done initializing the topic model, but we haven't actually created a topic model, right? We need to start updating these probabilities. So that random initialization that we did when we imported the random library, the thing is that, like, when you're creating something, you have to start from something, right? And so this is the main bug, especially when you're doing it by hand. When you say I want 5 topics, it's going to take 5 random words and just assign them to the topic. And what you're going to want to do, what it then does, like what the algorithm then does, is it also matches every single other word in the corpus to the topics randomly, but it's calculating the probability of that initial topic. Let me, show you. It's very long, but we're doing it iteratively. But what we're doing is, so the first 5 topics are randomly assigned and they stay there, right? So it really depends on the run. But every other word in your corpus is then randomly assigned to those 5 topics, and the probability of the relationship of those 2 words are calculated over and over and over again. And so you're going to, like, the topic model goes through so many loops until things stop moving. So for example, if we go back to that initial sentence, it's going to look at white in one topic, right? And then it's going to compare the word white to every other word in our corpus. And so it's going to test it against, like, building. It's going to test it against the word like cat, right? And for example, let's say the probability with the word cat is very low. So cat will then get tested to the next topic and the next topic until it finds the one with the highest probability, and then it stops, and that's where it's going to stay. And so then when our final topic model comes out, it's going to display the words that have the highest probability relative to that initial random word. And so let's see what I did. And so, nice, docs is not defined. What did I do? Sorry, let me check to see. I think here in the topic modeling, I might have pasted something in wrong. So I'm just going to paste it in again. Okay, And then we're going to go down and paste the probability in again. Okay, and so now we have a topic model. We just need to display it. And so it's the last step. And so in order to display the topic model, what we're going to do is we're going to print out the words that have the highest probability. And it's relatively straightforward, but it should, hold on. I forgot to print the top words. I also wanted to print something to separate each topic, and then I'm also going to print the top words. Okay, and so now we have topics. And so that Associated Press Twitter account that we scraped and sent to you, these are the 5 topics that it's coming up with. And so let's look at the quality for a second, right? We see that vote and nation are together. We see coronavirus is in multiple topics. I think 19 is probably referring to COVID-19. And so this is where your knowledge of your corpus really starts to matter. Virus and hospital are together. And so this can show you the different topics that are being covered in a corpus. And so I hope that that explanation kind of makes sense, because I want you to open up that topic modeling tool that we shared with you to start using it yourself, because this topic modeling tool is it's derived from the Mallet's GUI, the graphic user interface. And I really recommend you look into Mallet itself. Mallet runs through your terminal. And so it is a little hard for people to start off using, but it has a very powerful machine learning and text analysis software packages to actually use and run through your data. But the topic modeling tool is derived from Mallet, and it's a very easy, low learning curve software that we can use. And so I'm going to, I don't know if everyone got the sample corpus, but the sample corpus is actually from my first study, where I was looking at blog posts from the Democratic National Committee 1 month before the 2016 US elections. And so there are some settings here to take note about. I said here, I think these are defaults right now, but it says to post 10 topics. And if we go into optional settings, you can see a lot of the parameters that we just went over. Here, instead of stopping whenever there's no more movement, we're going to stop after 400 repetitions of that matching and pairing of the topics. We're going to tell the topics to print out their top 20 words. I think this has 10 or something. And I'm not entirely sure about the other parameters, but one thing that's super neat about Mallet is we make sure that this generate HTML output is checked, because once we generate the output and we say learn topics, I'll try to make this bigger, we end up seeing that, and it's fun to watch it work, we're able to actually go in and see which documents belong to each topic, which is something that what I shared is definitely not going to do that, but some of the libraries might. But this makes it super easy and approachable to do that. And so for my example, and this is where I think Ava and I will both speak about it more with our experiences with using Mallet, but everyone, I'm sure that all of your teams are going to end up getting completely different results, because that first word that's getting assigned there is completely random, right? There's no way to actually be this is what it's about, unless you give it context. And we can't really do that. So looking at some of these things, you might not, again, we need some sort of understanding of what's happening. in our text. So like the word chair appears here, right? But we know that because the context here is the Democratic National Committee, they're talking about the leader of the committee, whose name is Dana Brazil, or was Dana Brazil. I don't know. The Sunday editorial is together. Oh, this last one looks to be like it was about the debate and, oh my God, remember when this was America's biggest problem? And like the locker room talk and like that scandal that had happened. You can see here that Hispanic and Latino and Spanish are all together. And so you see that they've found the meaningful words that are unique enough, right? I'm sure there's only like 3 articles in there about Spanish at most, right? But they've distinguished that as a topic. But yeah, this is something where like, just to give you another example, let's say we want the top 10 words or the top 5 words, and we want it to go like 600 times so that it really does its best, what really gives me a distilled thing. Yeah. And while we do that, are there any questions about topic, like either kind of topic modeling?
Ada yang mau tanya? Is there any question? Suggestion?
If you want to see the HTML, like the actual articles that it's associated with, all you have to do is copy this and open up a new tab, paste it in. Hopefully it works. Yeah, and so there are my topics. And like, let's look at topic 3. And so what was topic 3? Because sorry, my browser is way too big right now. So topic 3 here, it says that it was economy, Clinton, jobs, years, economic. And so it's showing me, like, let's look at the first one that's there. It's telling me that this first article that we chose was a 92% match to this topic. And so it does a pretty good job of like matching it to the random topics that it does. And so like, if you're going to use this, I would recommend like playing around with the settings, do it like iteratively. And like the goal for you is just to get an idea of what's happening among a corpus that you can't possibly read in, you know, this amount of time that you have. And then if there aren't questions, I'm going to very quickly like share a tutorial that I found about n-grams, and then we're going to look at Voyant and wrap up by showing you a project that uses these tools. So while I go back to our topic modeling, okay. So, oh, and let me share the source both in the chat, but also in this so that I don't forget. Okay. I've literally, like, this is the exact same thing. But n-grams, what they are is n can be any number. And what the goal is to find words that are always appearing together. And so the example from earlier in the slideshow was White House, right? Like white on its own doesn't have much contextual meaning that's for us, right? We care when it's White House. And so there's words like that that are in pairings, or it could be 3 grams or 4 grams that really matter to us as researchers. And we want to be able to distinguish them and identify them. And so like very quickly, just in the example that Albert has shared, this is the sample text that he's provided. And we're just going to import a simple library, and just simply clean this up so that there's only lowercase words so that we don't, yeah, and we're replacing anything that's not alphanumeric with just a space, and splitting everything up into individual words. And then all we're doing here is we're concatenating means connecting. We're just connecting the tokens into grams. And so this works a lot better when there's like a huge corpus, but like just for the sake of this example, we can run it to see if it doesn't give us errors. And we can say we want to generate an n-gram with s, that sample text, and we want to say that n equals 5, right? Because here, when we define the function, we had those two variables. And so what happens? So you see that, I mean, this is a very short text, so it's not much meaning. There's a lot of repetition, but you see like natural language processing, NLP. Processing is an area of computer science, right? And so we see some things that are happening together. But I just wanted to also share that code with you to be able to identify when there's individual cases. You can also like search for specific two words that are together. There's like a lot that you can do that's like customizable. And you know, you can, if I did 2 words for this, I think it wouldn't work well. I think it'll just show, yeah, like this is the exact text one after another, because you're just saying what 2 words appear together, and well, the ones that are next to each other. Okay. I also, okay. I finally, well, let me close this out so that we can start it again. The final thing that I wanted to go through was called Voyant. And Voyant is just an online interface. And so there's no need to download and no need to sign up for anything. So if you can use it now and share, like poke around with it while we're going along, that would be great. And hopefully you'll have questions that I won't be able to answer. I'm going to upload that corpus. I'm going to upload it, not open it. There's a sample. So there's 2 options. I think Eva shared a sample corpus of the Democratic National Committee stuff. You can't, for some reason, Voyant doesn't let you upload a whole folder. Oh, and the topic modeling tool requires that it's a folder. Like it will not take like 5 documents. But with Voyant, you're able to select multiple files and open it. If you don't have the corpus readily available, you can just open and use the sample. There's like a Shakespeare sample and something else. But basically, this is like a very simple, very quick, like gives you an overview and some visualizations about what's happening. And so, you know, that data set that I shared with you is the post from the Democratic Committee 1 month prior to the election, right? And so naturally, the biggest word is not Hillary Clinton, it is Trump. Because we're not gonna go into it. But I'm just gonna start with just a very basic overview of each of these boxes. So the first is just a word cloud of the most common words. And if you hover over a given word, it shows you how many times it appeared. You can also toggle that to become just the list of terms. And I prefer the list. I don't like word clouds, but it'll show you like, okay, in that month, Trump was mentioned 118 times and Clinton was mentioned less than half of that. And the order that I uploaded in, I think the alphabetical order happens to be like the order by date. So this trend graph is actually accurate in terms of when in that month he was mentioned the most or least. Similar to over here, you still see that trends graph. But this is an overview of your entire corpus up here on the left. I don't know what links are. Oh, this is fun. So the links, if we separate them out a little, we'll see that the DNC, so the Democratic National Committee, is all on its own, and it has words like Donna Brazil, who was the chair of the DNC during that time, the interim chair. So you see that those words are always clustered together. And we were talking, I scraped the month before the election, so it was October. And so anytime she was mentioned, they were probably giving an update about what was happening in terms of their finances, because they have mandatory reports that they have to do. With Trump, funnily enough, the word president was put, even though it was before his presidency, and not with Clinton. Again, you wonder why. This could have predicted the elections. But the only word that actually has commonality, because this is a very small corpus, is debate, right? They were only mentioned during the debate together. And it also has here identified Trump, Clinton, and DNC as the key terms, right? Which is pretty cool. Like, it's showing you the strength of the tool. Here in the top middle, you will have a reader, which is really just like, if you have a question about a specific document, you want to be like, wait, which one was that? It can load it here and you can read that. It also goes in order of your upload. And if it loads, there's another visualization here about words that appear together. So like, I'm hovering over party, which appeared 19 times, but it says party leaders. You know, there's a DNC, like the Democratic National Party was also mentioned. And so when they're mentioned, there's a lot of other words that show up. When Americans are mentioned, we have make, don't know. Or when years is mentioned, we have Obama, like the Obama years was mentioned, or women. I don't know how many years women have been in power. Oh, at the end, there was a lot of celebration of like, a lot of women were the first in their state to get that role. And so they were like, in 51 years, this is the first person, and you know, things like that. Okay, the top right is also a visualization of trends, but the x-axis here is every individual data set. So you get a nice timeline of when words actually appeared most. And so we see that at the height of it, there's one article on the 10th of October where Trump's name was mentioned a lot. And you can also have that in terms of the raw count. And it shows you which document number and relative to the rest of the corpus, how common that word was. And again, the trend throughout the, well, what's this trend? Oh, the distribution of that word throughout the document. And then here at the bottom left, we have a summary table. And so this gives you just information about your total corpus. I probably should have started here. But basically, you know, it's telling you how long each document is on average, what the longest ones are, what the shortest ones are, the variability in what different kinds of words were used. So which one had like the most amount of unique words and which one had the fewest, average words per sentence, right? Like all of this like information. This is their distinctive words. And so this is its own version of a topic model. It's a refined version. I think this is a very good one because they've identified Spanish language, Latino, Hispanic, all in one line. They have Obamacare and health in one line. They have the Sunday debate. The debate was on Sunday, although they do have debate a couple of times. The Russian cyber attacks are all in one. And so you can see, I think these are the frequency of the words, and it's basically telling me what, oh, I'm sorry, it's not a topic model. It's basically telling me the keywords in every single article. And so like at a very snapshot glance, I'm like, oh, on October 8th, they've talked about like the Hispanic population, right? Like on October 10th, during that their 6th update of the day, they talked about the Sunday debates and that it was the second debate. there's a document view as well, where you can see all of that information about each document, like how many words per sentence. And I think this is like the variability of the words. Let me see. And then finally, we have phrases. And so, yeah, these are what they consider to be strategic phrases that show up throughout the corpus. And then finally, with this bottom right panel, Ava, you might have things to add afterwards. But we get a bunch of just other trends that are appearing. And so you can like, basically what this is like the most common word, as we learned in the first time, was Trump. And so it's telling us the words to the left and to the right of that key term that it's identified. And then finally, let's see. There's this other visualization of every single individual document. Oh, and those key terms that it had identified, it's showing you where in the document it shows up. And then the last one is the correlations. And I think because the corpus is too small, there aren't that many. But yeah, are there questions about this? I think that Voyant and Topic Modeling Tool are both very, they're very approachable. Like they're not going to break, like don't feel like you're going to get stuck. Just try different things, poke around. Like you can customize these things. So like here, like this is with relatively low context, we can increase it to a higher context and we get more words, right? Or we have more keywords. So like the way that as like when I was new to this tool specifically, I was just like poking around and like sliding the scales to see like, are there connections that I haven't made? Yeah. And I guess while we wait for questions, I wanted to talk about the project that Ava and I had actually worked on. And so we were introduced both the topic modeling tool and Voyant in a digital humanities class. And together, along with the rest of the class, there was a newspaper that was published in, it was a collegiate newspaper that was published in CU Boulder, or generally in Boulder, during the 1970s. And that, like those documents had been scanned. And what we did was we made it machine readable, as in we like literally scraped by hand the whole corpus because they were images. And then we cleaned every single file on our own by hand. And we together as a class came up with like a whole corpus of this newspaper. And we each took a different, like each group took a different project and we tried to analyze that. And so like that was my first experience with Voyant. And I hadn't read the whole corpus, right? We were each responsible for like a fifth, like a tenth, or like something very minuscule, like a 15th of the corpus. And so we had maybe read our own 15th, but like definitely not the whole thing. And so by loading the whole thing into Voyant, we were able to see some trends and get an understanding of what was happening over time with this newspaper that we were assessing. And I'm going to, oh, it's open, but it was called Digital El Diario.
I have shared it to the people. Already shared the link.
Oh,
yes.
Excellent. I just wanted to go to your project actually, and I can briefly go over mine, but just to show the different, that there's different topic models, right? Like Ava and I were looking at the same corpus and we had drastically different analyses about what was happening there. And so, yeah, she had published the total copies, but like, you know, Ava, how many times did you iterate? Like, how many different topic models did you do before you chose that one to like use?
I thought more than 20 maybe.
Yeah.
Yes, more than 20
That
now.
sounds right.
Yeah.
Yeah, same. And I don't actually know if there's a file size limit to Voyant. Are you aware of any? Our corpus was like a gigabyte of data. I don't know. I'm making numbers up. We had a fairly large corpus, and I think it was fine. I think it's just a matter of how long you're going to have to wait for all that information to load. Yeah. Are there any other questions generally about
From
anything? I'll check if
Aditya.
I missed anything.
From Aditya Siva.
Yeah. Yeah, I don't know if there's any limitations to the size. I think it's just going to be dependent on how long you have to wait for it to
Yes.
upload.
Yes, right.
Yeah.
So more than the size that you uploaded, it takes time longer rather than if you only like uploaded very simple data. And from Aditya, is there any feature for taking visualization?
Oh.
And embed? Yes, I did. I thought you can embed the data visualization from Voyant. Yeah, according to our experience, we can do that in our research.
May I?
Yes.
Yes, please, Michael.
Shiva, besides text mining, have you ever tried to do picture analysis or video analysis? And if you have, for what case and what method have you used?
I haven't yet. I'm about to start. And so I will share you some of my preliminary resources that I've gathered later, but I can't speak to that right now. But it's a great question, Michael.
Okay. If you, based on your opinion, have a difference between text analysis and picture analysis, difference in techniques or something to do our work?
Do your visualizations have text in them?
Yeah, especially my research for video analysis. So I want to compare with text analysis method for basic on your experience. Maybe I have some suggestion.
So I do know that generally visualization is more appealing and gets much more views, right? It's easier to look at a picture than it is to read a whole article. And so the amount of carefulness that one needs to take when creating the visualization is much higher, right? And so being misled by a visualization is much more likely than a whole article that you're reading. So in that sense, like, I think that that's like one of the key differences. And I think, like, especially with visualization, like if there's like they're sharing a fact, a statistic or data, right? The way that the data is actually presented matters a lot, right? Like I can give you a terrible graph that's like very high, like COVID numbers in Antarctica, right? But it's like, what is the x-axis? Like, what is the scale, right? Like those kinds of things really matter a lot more than if I give you the fact that I say, I saw it today, it said 80% of Texans that have been in jail were not actually charged for a crime who died of COVID. And you're like, oh my God, 80% of these people were not actually criminals, right? And then you look at the statistic and it's only 11 out of 14 COVID cases that died in prison. You know, it's 14, I mean, 14 people is a lot, right? But 80% feels like crazy. And so with numbers and then also with visualizations, like they need to be treated a little differently in that sense.
Okay, thank you, Shiva.
Yeah, I can recommend a few books that I'll send to Ava too. Let me write that down. Is there any other questions?
Any question, any thought?
I'm going to stop share screening if that's possible.
Yes. Bagaimana teman-teman? Any question, any thought? Jangan pecah ya kepalanya. Bagaimana? Kita masih ada waktu 5 menit. We still have 5 minutes before we wrap up everything. Is there any question, any thought? Yeah. So this workshop is only for introduce you with the tools, and maybe some of you already know about the tools, then maybe some of you knew the on these tools, but that would be fine, because we only want to introduce you and trigger your discussion. We can share through our Slack channel everything. So if you have any question, if you have any concern, so you can share it, and then with the others also. I'm sure there is a lot of people here more know well about this many tools, but so you can share with us in this forum. So for the newbie one, no problem. So we can learn together. It's not so difficult if you trying to do that. Is there any question? No? Siva, maybe you want to give it some tips or maybe something else?
I actually wanted to I said that I would pass along a lot of information on, and I want to make sure that I didn't forget any. And so I'm going to list them, and please, if you told me and I said I would do it, remind me now. I said that I would share some libraries that will help with visualization. And then also I remember just now the visualization representations versus text analysis. Ava has mentioned in the chat that ImageJ can be used. Thank you. But is there any other thing that came up? I'm trying to remember.
We will talk about the network analysis with the others speakers. So maybe all of you just
Excellent.
wait. We will talk about network analysis, and also we will talk about kind of like mapping, geospatial. So no worries. But Shiva, if you want to share anything, any tools or link or something, please, it will help for us. Since now we are trying to develop some prototype on digital humanities.
I'm really excited for what you all have to do. Seriously, you know, like I'm originally from Iran, and like I really wish that there were people in Iran doing the same thing. And if I'm really proud of you, but I'm happy that there's so many people that are interested. I think it's really important work.
So anyone to ask last question, thought or comment? No? How is Mas Wildan? Everything is okay, Mas Wildan?
Everything is okay. I'm trying to understand more and more.
Raudo, you want to say something? Or Dian?
Okay, I want to say some words, I guess.
Please.
I just want to thank Siva for having this topic. This is a really interesting topic, of course. And I know that some of us maybe have difficulties to understand, but this is really interesting topic, and this is open our mind that programming is not only about tabular data, but we also can have some insight from text. I think from today's session, we got some new knowledge that wow, there are a lot of things, and there are a lot of cool things that we can do with programming with data. I think that's all I want to say.
Thank you so much. It was very kind.
Okay. So maybe Siva, we want to close the session. If you have some maybe final thoughts for us.
No, I mean, just know that these are really approachable tools. There's tutorials anywhere. Like if you decide to go down the Python route and you get an error, just Google the error. Someone has had it. And yeah, that these tools you can use them for like a very introductory, analysis of what's going on when there's too much data to read yourself. But that's really it. Thank you all so much for joining, and thank you for your questions. Yeah.
Okay. Before we end the session, we will take pictures all together. But before that, maybe I want to say something, inform them about something. But in bahasa, you don't mind, just? Okay. So teman-teman, jadi kita sudah selesai dengan yang session untuk ini, untuk yang text mining. Jangan khawatir, mungkin beberapa teman-teman yang masih newbie, for anyone who still newbie, nggak apa-apa, karena ini memang perkenalan, kita memperkenalkan memang dari tools yang sepertinya sangat kompleks seperti Python sampai dengan yang cukup simple. Ini supaya bisa teman-teman bisa memberikan gambaran umum aja sih, banyak hal yang bisa dieksplor dengan teman-teman. Jadi data dalam bentuk teks nggak cuma akan ditampilkan dalam bentuk grafik, benar tadi kata Mbak Roda tadi, tapi banyak hal yang bisa dieksplor di data dari bentuk teks. Nah, mudah-mudahan sesi from SIPA hari ini bisa menambah perspektif teman-teman bagaimana untuk bekerja dengan data dalam berbentuk teks, bagaimana bisa menganalisisnya, bagaimana bisa menghasilkannya jadi suatu proyek yang menarik dan bisa disimak oleh orang banyak. Pengumuman saja buat teman-teman, untuk semua workshop nanti semua materinya selalu akan diberikan di-sharing melalui channel workshop, channel Slack workshop. Tolong teman-teman update di sana, karena itu semua akan diberikan, termasuk nanti ada informasi dari Shiva, the information from Shiva, we will give it through the Slack channel. So we have a Slack channel Shiva, if you want to join, please, but always in bahasa. So nanti akan di-share di sana semuanya, dan beberapa tadi juga modul sudah sempat di-share, udah kami share, dan selalu tolong update di sana, karena nanti untuk workshop besok persiapannya juga akan kami share di Slack channel workshop. Lalu juga untuk Slack channel project, mungkin teman-teman bisa update juga bagaimana sih update teman-teman sampai hari ini, boleh sharing, boleh juga bertanya, atau anything yang teman-teman mau sampaikan di Slack channel. Kemudian kalau untuk hal-hal lain di luar itu silakan heads up di Slack channel general. Kita selalu berkontak di sana ya, supaya teman-teman masih tetap keep on track untuk prototipe-nya, karena ini sudah hari keempat sejak opening, mudah-mudahan sudah punya banyak progres, dan besok kita akan bicara soal mapping dan geospatial, dan ini akan menggunakan Mapbox, nanti akan di-share tools-nya di Slack channel, teman-teman bisa download, dan besok kita akan workshop kembali tentang materi tersebut. Mungkin itu saja teman-teman, waktunya sudah hampir selesai. Terima kasih, kita foto bersama dulu. Mbak Sarah, Sarah ada yang mau disampaikan? Is there any information that you want to share to us, Sarah?
Enggak Mbak, aman. Paling kalau misalnya nanti teman-teman membutuhkan video untuk kegiatan hari ini atau mungkin kegiatan yang kemarin, semuanya bisa diakses lewat YouTube channel kita di Asosiasi Media Siber Indonesia.
Oke, jadi yang nggak ikut session hari ini disampaikan, Boris, nggak apa-apa, rekamannya bisa disimak ya teman-teman. Dan mungkin yang ikut session hari ini yang masih kepalanya masih pusing sekali melihatnya, bisa diulang lagi, nggak apa-apa teman-teman. Jadi nanti lihat di YouTube channelnya Mas AMSI, Asosiasi Media Cyber, dan jangan lupa untuk di subscribe. Ini pesan dari sponsor.
Yes.
Oke teman-teman, kita foto bersama dulu ya, Sarah, boleh dipandu.
Oke, baik. Boleh teman-teman menyalakan kamera dulu.
Let's take a picture, Siva, together with all of us. Yes.
Oke, saya hitung di slide yang pertama. 1, 2, 3. Oke, slide kedua. 1, 2, 3. Oke, sudah.
Oke. Okay, everyone, thank you for today. Thank you, Siva. Thank you so much for your time today. And good night, Siva. Oke, teman-teman.
Nice day, everyone.
Bye.
Thank you, Siva. Bye.
Bye. Thank you. And Ava, please, if anyone has questions that you don't want to answer,
Yes,
you can
I'll
send them over.
I'll send it to you.
Bother Steve, he will answer for us.
Thank you so much, Siva.
Anyway, yeah. Good night. Bye,
Yeah, have a
everyone.
good